I'm going to go over the Quadratics quiz review now. So I'm going to go through a few examples of each type of problem. I'm not going to do everything. It's going to take forever if I do that. It's going to be a really long video. But I'll do a few examples of each type of question. And I'm going to go kind of slowly and provide as much detail as I possibly can so that those of you that may be struggling with certain steps can hopefully understand better why we're doing certain things. So for the first two, we're going to sketch the graph of each function, identify the vertex, axis of symmetry, and the solutions to these functions. So if you need more help with this, you're going to look at this worksheet from class, the vertex form of a quadratic function. So this is going to give us the vertex, right? The vertex is going to be xy value. The x value is h, and the y value is k here. So if you notice, h is the number inside of parentheses with x. It could be minus or plus, x minus or plus something. And then k is the number at the end of the function that is either plus or minus, right? So if you look at both of our functions, number 1 and number 2, you'll notice that 1, they don't have parentheses, and 2, there's no number at the end. It's just an a value and then x squared. So this tells us that since there's no parentheses, there's no number that's x plus or minus inside of parentheses, that means that the x value in our vertex is going to be 0. And since there's no k, meaning that there's no number at the end of the function that's plus or minus, y value is also going to be 0. They're both missing. So we've found our vertex. Our vertex is 0, 0. Okay, and on the back of this worksheet, I'm going to do another graphing, and that one is going to have it's not going to be 0, 0 like this. It's going to look a little different. So you'll be able to see both types. Okay, so now that we've gotten our vertex, we can get started on filling in our xy table. Right, so we're going to write out an xy table. I'll have this for you on the day of the quiz. So first I got my xy table. I'm going to put 0, 0 in the center, and I'm going to graph that point right here, which is right at the origin. So if you remember from class, what we want to do next is we want to pick 2 points. Oops, sorry. We want to pick 2 points. We're going to be, so here's our vertex. X value is 0. We want to pick one value that is exactly 1 to the left and 1 to the right of our vertex, right? We want 2 points that are the same distance from our vertex, 1 on each side, because since parabolas are symmetrical, if I pick 2 points that are the same distance from my vertex, the y value is going to be the same whenever I plug it into the function, so it just makes it less work for me, right? So 1 to the left of my vertex, which is at 0 for the x value, is going to be -1. So I'm going to write that in. And then 1 to the right of that is +1. Okay? So these two x values are the same distance from our vertex. And if you remember, the vertex is the point on the parabola where the two symmetrical lines split off from. And since it's symmetrical, it doesn't matter which one of those two values I plug into my function, I'm going to get the same y value. So it saves me work. I only have to plug in one of those. And it's probably going to be easier to plug in just one, right? So I'm going to do 1/2, and I'm replacing x with 1, and then it's squared, right? So when you square a value, what you're doing is you're multiplying that number times itself, right? So we're going to follow the order of operations as well, which I wrote up here, Pemdas. So parentheses goes first. That's already done. Exponent is next, and then multiplies after that. So first we're going to do the exponent here, which is 1 squared. So 1 squared is just 1 times itself, which gives us 1. So we're left with 1/2 times 1. All right, and then next I have 1/2 times 1, which is just 1/2. Right, any number times 1 is just itself. So, and here it goes in intervals of 0.5. 1/2 is the same as 0.5, so I'll just write 0.5. So I'm going to graph those points. I'm at 1 and 0.5, and then I'm also at -1 and 0.5, which is right here. So there I got those 2 points graphed. Next, I want to pick another 2 values that are the same distance from our vertex, and that is going to be -2 and +2, right? Both of those are 2 units away from our vertex, so regardless of which one I plug in, I would get the same y value, okay? So I'm going to go ahead and erase that. This time I'm going to write 1/2. I'm replacing x with, I'll do -2, and then squared. So we're going to do exponent first. So -2 squared, that is going to be -2 times -2, which gives us +4. So now I have 1/2 times 4, and 1/2 times 4 is going to be 2. If you multiply anything by 1/2, it's just going to be half of that number. So half of 4 is 2. So both of these are 2 right here. And I'm gonna graph those 2 points now. So one is right here, and the other one is right here. And that's enough to connect. I'm not sure why the graph was given in this way, but on the quiz I also only need you to fill in 5 xy values. So that's good enough now. All right, so that's what our graph looks like. So now we're going to look for, we already have the vertex. Next is the axis of symmetry. And if you remember what I told you in class, the axis of symmetry is going to be x equals, and then whatever the x value in your vertex is. So the x value in my vertex is 0. So I write in x equals 0. So that's the axis of symmetry. And then the solutions, if you remember, the solution to a quadratic function is where the parabola crosses the x-axis, or where it touches the x-axis if it doesn't cross. So we only have one solution here. It only touches the x-axis once, and that is at x equals 0. So you're going to write x equals, you always want to include your brackets, and then 0. This distinguishes it from you writing the axis of symmetry or an ordered pair or anything like that. So x equals 0. There's only one solution there. So I hope that made sense. Go ahead and try number 2 now. I'm going to move on to the next section. I'm going to do another graphing at the end because the last 2 questions on this quiz are also graphing. Okay, so for this next section, we're going to be solving by factoring. So from number 3 to 12, we're going to be factoring. I'm going to show you a few examples of each. I'm not going to do them all, so you guys can try some of them on your own. So for number 3, we have m squared plus 8m plus 12. So that's standard form. And if you need some refresher on how to factor, you're gonna want to look at solving quadratics by factoring. And here's the 4 steps that you're going to take when you're factoring. So number 1 tells us to move all terms to one side and set the equation equal to 0. So on the right side, we're going to want a 0 to be there. So we want to get rid of everything on the right side. Step 2, factor. Step 3, set each factor equal to 0 and solve for the x value. And then we're going to write our answer as a solution set inside of brackets. Okay, so for number 3, to factor this type of problem, if you'll remember, the way that we've set it up is a plus b equals and a times b equals. So we're gonna look for 2 numbers. They're gonna add up to 8, right? That's gonna be the a plus b. A plus b is gonna be the number that is in front of your variable, so just in front of m. So a plus b equals 8, and then a times b equals your constant, the number at the end of your function, which is 12. So a times b equals 12. So I'm going to look for 2 numbers that satisfy both of these equations right here. So the way that you're going to do it is you're going to look at 12 and you're going to make a factor tree for it. And this may be useful to you. So before I get started on that, let's do this real quick. So if you guys remember this from class, a positive times a positive equals a positive. A negative times a negative equals a positive, and then a positive times a negative equals a negative. So what I'm trying to get at with this stuff, so if your a times b is positive, both of your signs are either going to be positive or negative. And what's going to indicate if they're both positive or negative is going to be the a plus b. So if a plus b is a positive number, both of your signs are positive. If your a plus b was a negative number and your a times b was a positive number, both of them would be negative, right? Now, if your a times b is a negative number, you're going to have 1 positive and 1 negative number for a and b. Okay, so here my product is positive and my sum is positive, so that means that both of the numbers that I choose for a and b have to be positive. Okay, so let's go through the factor tree of 12. We're going to look for just 2 numbers that multiply to 12. We'll start off with 1 times 12. If you were to add 1 and 12, they do not equal 8, so these do not satisfy both of the equations. Next is 2 times 6. And if you added them up, 2 plus 6 is 8. So those are our two numbers, right? So once we figure out what A and B are, we can write them into our factors, right? And then the factors are just x plus A times x plus B, right? So x plus A, we'll say A is 2. X plus B, we'll say that B is 6. So x plus 6. I'm going to erase that so it doesn't confuse us, but I just want to show you guys again why we write it this way. Okay, so now that we've factored, what we're going to do is we're going to set each of these factors equal to 0. And the factors are going to be the terms that have x, which is this one and this one. So we're going to set both of those equal to 0, just like we have here, and then solve for x. So x plus 2 equals 0, and then x plus 6 equals 0. So I'll start off with x plus 2. To solve for x, I got to get rid of this plus 2. So I'm going to do the opposite, and I'm going to subtract 2. And what I do to one side of the equation, I got to do to the other side of the equation as well. So I get x equals, these cancel out, and then 0 minus 2 is negative 2. So that's my first solution. Next, I got to get rid of this 6 that is with x. So I'm going to do the opposite sign. I'm going to subtract 6 from both sides. These cancel out. I get x equals, and then 0 minus 6 is negative 6. So those are my two solutions right there. So x equals negative 2, negative 6. And it doesn't matter the order that you write them. This portion is going to be multiple choice, so you might see x equals negative 2, negative 6, or you might see x equals negative 6, negative 2. It doesn't matter the order. As long as they have brackets, it tells you that that is a solution set. All right, I'm going to go over number 4 real quick. So for number 4, you'll notice that it's different from number 3 because it doesn't have that middle term that has the singular variable, right? So we just have p squared minus 9. So this one's actually going to be really simple because since you only have one variable, you can go ahead and solve for that immediately. So what I mean by that is I'm going to get rid of this 9, and then I got to get rid of this squared right here, right? So first I'm going to add 9 to both sides, right? So this cancels out, and what I do with one side of the equation, I got to do to the other side of the equation. So I get p squared equals 9, okay? So now I just got to take the square root of both sides. So p squared, the square root of p squared is just going to be p, and then the square root of 9 is plus and minus 3. So p equals positive 3 and negative 3. So p equals, and then in brackets, let me try to draw that better. P equals 3 and negative 3. And that is our answer right there. Hopefully that one was simple. All right, so I'm going to go on to number 6. So you got, well, actually, I'll do number 5, and then you guys try 6 on your own. And I'll have the answers posted as well. Okay, so for number 5, we have 7n squared plus 28n plus 28. What we're going to do first, and remember, whenever you have a quadratic function, the first thing that you're going to always look for, if there's a number in front of your variable squared, in which right here we have 7n squared, whenever there's a number that isn't 1 in front of your first term, you need to see if there's a greatest common factor. So I'm going to see if I can divide 7, 28, and 28 all by the same number. And we actually can, right? They're all divisible by 7, so I'm going to factor out a 7, meaning I'm going to rewrite this equation. I'm going to write 7 on the outside with parentheses, and I'm going to divide each term by 7, and that's what's left over inside the parentheses, right? So 7n squared divided by 7 leaves me with just n squared. Then I have 28n divided by 7, and 28 divided by 7 is 4, right? So I have plus 4n, and then plus 4. All right. So now we're going to ignore this 7 because it doesn't matter. It's not going to be part of the solution. We just had to simplify this function so that we could factor. So now that there's no number in front of n squared, we can factor this, right? So I'm going to set up a plus b. Let me write that a little bit better. A plus b and a times b. So a plus b is going to be the number in front of just this singular n, which is 4 right here, right? A times b is going to be the constant at the end of the function, which is just 4. All right, so now I'm going to make a factor tree for 4. And if we look back to our reference here, both the a plus b and the a times b are positive. So that means that we're in this situation right here. So both of our numbers are positive. So I'm going to make a factor tree for 4. 1 times 4. That doesn't work because 1 plus 4 is not 4. It's 5, right? Next is 2 times 2. And those numbers work, right? 2 times 2 is 4, and 2 plus 2 is 4. So we can write 7 n plus 2 times n plus 2. And so we're going to set the factors equal to 0. And remember, the factors are just the numbers that have the variable. This 7 doesn't have a variable, so we don't have to do anything with that. And since these are the same thing, we only have to do it once, right? I only have to do n plus 2 equals 0 once. It would just be redundant if I do both of them. So the next thing I'm going to do is I'm going to subtract 2 from both sides. And I get n equals negative 2. So this one has just one solution. So it only touches the x-axis once. So we get n equals, and in brackets, 2. And that's all there is to that one. Number 6 is an example just like this one. So I want you guys to go ahead and try that. I'm going to have the answers posted. And now I'm going to do number 7. So for number 7, if we look back at our steps, the first step is to move all terms to one side of the equation so that it equals 0. So we want the right side to equal to 0. So to make this equal to 0, I'm gonna eliminate this and eliminate this. So the way to eliminate it, I'm gonna add 8 to both sides, and I'm gonna add 44x to both sides. So these all cancel each other out, and 8 plus 8 is 0, right? Negative 8 plus 8 is 0. Negative 44x plus 44x, also 0. So that's how we are going to get 0 on the right side of the equation. So none of these terms mix, right? None of these are like terms, so we can't combine them. So what we're going to do is we're going to write 20. They don't combine. So we're going to write 20x squared plus 44x plus 8, and then it equals 0. All right, so next thing we got to do, we're going to look for the greatest common factor. So 20, 44, and 8, are they all divisible by something? And they're all divisible by 4, right? So we're going to factor out of 4, meaning we're writing 4 parentheses, and then we divide everything by 4 and just write what's left over. So I have 20x squared divided by 4, which is 5x squared. Next I have 44x divided by 4, which is plus 11x. And then I have 8 divided by 4, which is just plus 2. Okay, so we just factored out the greatest common factor. However, we still have a term. We still have a number in front of x squared. So I hope you guys remember what we do in that situation. In that situation, we need to rewrite our equation. And the way that we're going to rewrite our equation is we're going to take this number, the number in front of x squared, and we're going to move it to the back of the equation temporarily by multiplying it in the back, right? So, and I'm going to ignore this 4. I don't need it anymore for my solution, so I don't need to rewrite it anymore. So I'm going to write x squared. This 11x is unchanged, right? It was unaffected. The reason I wrote x squared is because I moved this 5 to the back. All right, and then at the end, I multiplied 2 times 5, right? So now I have plus 10. So now I can do a plus b, a times b. And a plus b is going to be 11. A times b is going to be 10. So I'm going to look for 2 numbers that add up to 11. And if you multiply them, they equal 10. So we're going to make a factor tree for 10. We're going to do 1 times 10. And that actually works. That first set works, right? 1 plus 10 is 11. 1 times 10 is 10. So we write x plus 1 times x plus 10. Now, one last thing before we can solve, since at the beginning of this equation, or at the beginning of the factoring process, since we multiplied by 5, now we have to reverse that and divide both of our terms by 5. Right? So for that first factor, it stays the same. We get x plus 1 over 5. 1 is not evenly divisible by 5, so we'll just leave it that way. And then with the other factor, x plus 10 divided by 5, Well, 10 divided by 5 is 2, right? So we'll write x plus 2. Now we set both of those factors equal to 0. X plus 1 over 5 equals 0. And x plus 2 equals 0. I'm going to subtract 1 over 5 from both sides. And we get x equals negative 1 over 5, right? Since we subtracted it, negative 1 over 5. And then over here, we're going to subtract 2 from both sides. You get x equals negative 2. So those are our two solutions right there. X equals negative 1 over 5, comma, negative 2. All right, I hope that made sense. Number 8 is really simple. For number 8, we're going to find the greatest common factor, right? There's no constant, so we can factor out an x. Both of our terms have x, and 16 and 20 are both divisible by 4. So we can factor out 4x, and then we write what's left over. So divided by 4x, divided by 4x. Okay, so 16 divided by 4 is 4. X squared divided by x is just going to leave us with just x, right? And then 20 divided by 4x, well, 20 divided by 4 is 5. And x divided by x, those cancel each other out. It's just 1. So this is what we have left. And if you wanted to confirm, you could just do 4x times 4x, which is 16x squared. 4x times 5, 20x. So we know that we did this correctly. All right, so equals 0. And now what we have to do is we're going to set our terms equal to 0. So this is my first term. This is my second term. 4x equals 0. And then 4x plus 5 equals 0. So to solve this one first right here, I have 4 times x. So to get rid of that 4 in front of x and get x by itself, I'm going to do the opposite function, divide both sides by 4, right? These cancel out. They just become 1. And then x equals 0 divided by 4 is just 0. 0 divided by any number is always going to be 0. Okay, so that's our first solution. For the second solution, we have 4x plus 5. First, I'm going to subtract 5 from both sides, right? I'm slowly working towards isolating x. So I get 4x equals, and then 0 minus 5 is negative 5. Divide both sides by 4. And we're going to leave that as a fraction, right? I can't divide 5 evenly by 4, so my answer is going to be negative 5 over 4. So x equals bracket 0 and negative 5 over 4. That is the points where the parabola crosses the x-axis. So on this backside, I'm only going to do number 10 for the factoring portion. Every other question you should be able to figure out using at least one of the steps from all the other problems. They're all similar, so there'll be at least like one of the problems that we did on the front. So I'm just going to do number 10 and then let you guys work on the rest. So the first step, remember, we want to make this side equal to 0. So we got to get rid of everything on that side. So first I'm going to add x to both sides. And then I'm going to add 2x squared to both sides. So these cancel out. Negative x plus x is 0. Negative 2x squared plus 2x squared is 0 as well. So we have 0 on that side. So what I'm left over with is 2x squared. I'm going to do the x next. So I have negative 4x plus x, which gives me negative 3x. And then minus 2 equals 0. Okay, so the first thing you want to do, you want to look for greatest common factor. However, here there is no greatest common factor. I can't divide 2, 3, or negative 2 by the same number. So we move on to the next step, which would be to rewrite the equation. And when we rewrite the equation, we want to make sure that when we rewrite the equation, we want to make sure that there is no number in front of x squared, since right now we have a 2. So we're going to rewrite it by first moving this to the back of the equation by multiplying it. Remember, this is called the AC method. So I have x squared minus 3x. Negative 3x was unaffected. And then instead of writing negative 2, I multiplied that 2 from the front. So this would be negative 4 equals 0. So now we can solve, right? A plus b, a times b. And let me write this this little diagram that I had for you guys earlier again. positive times a positive equals a positive. Negative times a negative equals a positive. Positive times a negative equals a negative. Okay, so a plus b is going to be negative 3. A times b is going to be negative 4. So this time I have a negative product. So that tells me that to get a negative product, you have to have two signs with the opposite, or sorry, two numbers with the opposite sign. So one of these numbers is going to be positive, and one of these numbers is going to be negative. One is a, either a or b will be positive, and then the other one will be negative. And the way to find out which number is going to be positive and which one is negative, you look at a plus b. So the sum of the two numbers is going to have the same sign as the larger number. So since this number is negative, the larger number from our two factors should be negative as well. So we'll start off with the factors for negative 4. So I have 1 times 4. And remember, the larger number is negative. And this works, right? 1 minus 4 is negative 3. And 1 times negative 4 is negative 4. So those two numbers work. So we already found our factors. So we're going to write x plus 1, x minus 4. And then the last thing we got to do before we solve, since we multiplied by 2 at the beginning, we're going to have to reverse that and divide both by 2, right? That was just temporary. So now I have x plus, I'm going to just keep it as 1/2. 1 divided by 1 is not evenly divisible by 2. And then x, negative 4 divided by 2 is just negative 2. So I'm going to set both of those factors equal to 0. X plus 1/2 equals 0. And x minus 2 equals 0. So for the first one over here, I'm going to subtract 1/2 from both sides. I get x equals negative 1/2. And then on the other one, I'm going to add 2 to both sides. And I get x equals 2. So for number 10, our solutions are x equals negative 1/2, comma 2. Again, it doesn't matter the order that you write them. The quiz is going to be multiple choice, so you can look for that answer. It might be negative 1/2, comma 2, or it might be 2, negative 1/2. Okay, so now I'm going to go into the graphing. And if you look at this one, this is a lot closer to our HK vertex form that we saw, right? So if you remember, if you want to look back at the beginning of the video, we're going to first sketch the graph of each function, identify the vertex, axis of symmetry, and the solutions. So first we got to find our vertex, right? So let me write that down right here, vertex, axis of symmetry. I'm just going to write axis. You guys know what it means, and then solutions. Okay. So remember, the vertex is going to be, the x value is going to be the number inside of the parentheses with x, but with the opposite sign. So since we have plus 4, here it's going to be in the vertex is going to be negative 4, right? And then minus 1 stays the same. That's our y value in our vertex. All right, so we just found our vertex. I'm going to go ahead and write it down right here. It was negative 4, negative 1. All right, so we can start off by graphing that point right, which is right here. This graph's a little weird, but it's okay, because we don't really need to graph anything to the right side. What you'll see once we have this function graphed. All right, so we're going to make our xy table. And on our xy table, we're going to first write our vertex, negative 4, negative 1. And remember, we're going to pick 1 point to the left, which is negative 5, and 1 point to the right. Those are the same distance from our vertex. Negative 5 and negative 3 are the same distance from negative 4. So since parabolas are symmetrical and they are the same distance from our vertex, the y value is the same. So I only have to plug in one of those. So I'll pick negative 3. So I got 2 times negative 3 plus 4 squared minus 1. Remember, we're following order of operations, Pemdas. So the first thing is parentheses. So we're going to do what's inside the parentheses first. So I have negative 3 plus 4, which is just 1. Next is exponent. Oh, and then we have minus 1 at the end. Can't forget to write that. So next is exponent. So I'm going to do 1 squared. Remember, 1 squared is just 1 times 1. So I have 2 times 1, and then minus 1. So in order of operations, next is multiply. So we do 2 times 1, which is 2. I have 2 minus 1, which then is just 1. Okay. So I'm going to write in these points right here, 1 and 1. And if you would have plugged in negative 5, it would be the same thing, right? Negative 5 plus 4 is negative 1. Negative 1 squared is positive 1. 2 times 1 is 2. And 2 minus 1 is 1. So you would have gotten the same thing if you plugged in 5. And we know that because they are the same distance from our vertex. Okay, so let me graph those 2 points. Negative 3, 1, and negative 5, 1. All right. And remember, this is a vertical stretch, so it's going to be a little bit skinnier than our other graphs. All right, so now I'm going to pick 2 more points, 2 to the right, and then a point that's 2 to the left. So that's negative 2 and negative 6. And we only have to plug in one of those. I'm going to choose negative 2. Or actually, I'll choose negative 6. So we have 2 times negative 6 plus 4 squared minus 1. All right, so negative 6 plus 4, that is going to be negative 2. Next, exponents, negative 2 squared. That's just negative 2 times negative 2, which is positive 4. So I got 2 times 4 minus 1. And next is going to be the multiplication. So 2 times 4 is 8. And then 8 minus 1 is 7. So both of those points right there are going to be 7. So I can go ahead and graph those. So negative 2, 7. And negative 6, 7. So we can connect those points, make it look a little bit better. And that's what our graph should look like, right? Once you have your graph and your XY table completed, let's go down to the axis of symmetry. So with the axis of symmetry, remember it's x equals and then negative 4, right? It's the same x value as the x in your vertex. So for the solutions here, this was not a very good example in terms of solutions because you can't really see what that solution is. However, it is going to be negative 3.5 and negative 4.5. The examples that I give you on the quiz, they're going to be a lot more clear. They'll be exactly on the x-axis at a whole number. So sorry about this example. It's not a very good one because the solutions are not very clear. They're going to be a lot more clear on number 14. So let's go to number 14. So first thing, we're going to identify the vertex. So remember, this is the x value, but with opposite sign, so negative 1. And then this is the y value. So negative 1 is our vertex, sorry. So I'm going to go to negative 1, which is right here. I'm going to go to my XY table. And you should have the hang of it by now. So we're going to pick one number to the left, one number to the right, which is going to be 0 and negative 2. Both of those numbers are exactly 1 point away from negative 1. So whichever one I plug into my function, it's going to be the same thing, right? So I'm going to plug in 0. So I'm replacing x with 0. So 0 plus 1 squared minus 1. So 0 plus 1 is 1. So I got 1 squared minus 1. 1 squared is 1. And then minus 1 is 0. 1 minus 1 is 0. So both of these are 0. So negative 2, 0, and 0, 0. Okay, I'm going to pick now 2 points that are two units away from my vertex, which are 1 and negative 3. It'll probably be easier to plug in 1, right? So I got 1 plus 1 squared minus 1. 1 plus 1 is 2. So I got 2 squared minus 1. 2 squared is 4. Minus 1. 4 minus 1 is 3. So both of these are 3. And again, you could have plugged in -3. -3 plus 1 is -2. -2 squared is 4. 4 minus 1 is 3. Same thing, right? So we got 1, 3, and -3, 3. Okay, so let's fill in. Now that we have our graph and our XY table done, we're going to fill in these blanks. Vertex is -1, 1. Sorry, -1, -1. The axis of symmetry, x equals, and then the x value here, which is -1. So x equals -1. And then the solutions, both of the examples on your quiz are going to be this, just like this. You see how it's very clear that our solutions are right there on the x-axis. And for the solution, you're going to write what the point is, just the x value. So this one, the x value is -2. That's one solution. And then this one is 0. So our two solutions to this are -2 and 0. And if you want to look at it on your xy table, wherever y is 0, that x value is your solution, which we have 0 and -2. All right, if you have any questions, please let me know, but this is exactly what your quiz is going to be like. The solving by factoring is going to be multiple choice, and the graphs are not going to be multiple choice. Hope this helps.